Now this problem says 3,3-dimethyl-butane butan 2-ol. So we have 3,3-dimethyl butan 2-ol so when this compound loses a water molecule in the presence of conc H2SO4, so this is treated with conc H2SO4, so we have conc H2SO4, and the question says it loses one molecule of water, so that is minus H2O. To give a tetramethylethylene as major product, suggest a suitable mechanism. So this gives tetramethylethylene. So the product you have, so name of the product is, so product you are getting tetramethyl, so tetramethylethylene. So tetramethylethylene as the major product. So let us first write down the structures and then we'll discuss. So 3,3-dimethyl-butan 2-ol. I think all of you can write. So you have butan, that is 4 carbon, 1, 2, 3, 4. And at position number 3 you have 2 groups. So this is 1, 2, 3, 4. At position number 3 you have 2 methyl groups. So is this I can write here 1, 2, 3, 4. So position number 3 you have 2 methyl group. So 3,3-dimethyl and butan 2-ol. At position number 2 you have OH group. So here you have OH group attached. So this is the reactant, and now if you treat this reactant with conc H2SO4, dehydration takes place and the product is tetramethylethylene. So ethylene is C double bond C, and you have 4 methyl group. So you can have Me here, Me here, and this Me and this Me. So you have to write down the mechanism for this reaction. So this is your dehydration of alcohol and this is alkene. So this is alkene and this is alcohol, and reaction is dehydration of alcohol gives alkene. I think all of you can write down the product mechanism. So let me wait for 1 minute. It's an easy problem. Yeah, you are basically right in this case. So first step is this. You have CMe, Me, COH. I have to show the lone pair also. And then you have C. In the first step you take H plus from H2SO4. So this H plus will make good leaving group alcohol. So in the next step you will have C, Me here, Me, CH, and then you will have OH2 plus. Are you getting or not? So it will have OH2 plus, and this side you will have carbon. Now this H2O will lose, so you will get a carbocation. So C, and here you have CMe, and you have one more Me, and you have a carbocation. And now you know this is a secondary carbocation. So in the next step there will be methyl shift. So if I shift this methyl group, so that is the rearrangement of carbocation through methyl shift. If I shift this methyl group here, so I will get something like this. So CMe, here you have Me, but at this carbon, because I have already shifted one methyl group, so you will have one methyl, one carbon, and there will be a hydrogen and there will be a plus charge. So on this carbon there will be a plus charge. Now in the next step, if you lose H plus, so that you can get an alkene, so you will have C, and this will have a Me, and this side this is a CH3, that is again Me, So I can put this as a Me. And now there will be a double bond, and then you will have C, and this carbon will also contain one Me this side, another Me this side, so you will have two Me group. So you will have, finally the product will be C double bond C Me, Me. So that is tetramethyl ethylene. Are you getting? Now this is a very easy problem. Only thing is in this problem is rearrangement of carbocation. Mechanism will be E1 because it's elimination reaction, but happens through carbocation. So mechanism of this reaction is E1. Elimination by unimolecular because it happened through a formation of a carbocation, and the carbocation rearranging. So this is a reaction of dehydration of alcohol in the presence of conc H2SO4 via even mechanism through methyl shift, that is rearrangement of carbocation. So these are the important points we have in this reaction. We'll discuss the next problem.